Hello dear students, welcome to this session. In previous session, we have discussed unit step function and shifted unit step function, Laplace transform of Heaviside function or unit step function, both are same with different names. Then second shifting theorem and some examples on second shifting theorem. In this session, let us discuss some more examples on second shifting property. Before that, let us recap the definitions what we have discussed in our previous lecture. That is definition of unit step function, that is u of t equal to 0 for t is less than 0, 1 for t is greater than or equal to 0, and Laplace transform of unit step function u of t, that is 1 by s. Then shifted Heaviside function or shifted unit step function u of t minus a, which is equal to 0 for t is less than a, 1 for t is greater than or equal to a, and Laplace transform of shifted unit step function, that is u of t minus a equal to e power minus as upon s. Then we have discussed second shifting property, that is L of f of t. If L of f of t equal to f of s, then L of Laplace transform of u of t minus a into f of t minus a equal to e power minus as f of s. Other form of this second shifting property is, if L of f of t equal to f of s, then L of capital F of t equal to e power minus as f of s, where capital F of t equal to small f of t minus a for t is greater than a, 0 for t is less than a. So if you observe here, u of t minus a into f of t minus a is nothing but capital F of t. So capital F of t can be expressed in the form of u of t minus a into f of t minus a. How means, here if f of t, capital F of t equal to f of t minus a, here limit is t is greater than a. This can be written as a is less than t. And here 0 for a is greater than t, or you can keep it as it is, no problem. T is less than a. Anyway, this is 0. Now, you can write it as f of t minus a into, see this lower limit. Lower limit can be written as u of t minus a. Here, if lower limit is a, we can write in the form of u of t minus a. And here this is 0. So here we get only this term. So f of t can be written as f of t minus a into u of t minus a, or u of t minus a into f of t minus a. Both are same. Okay. So this is, means we have expressed this f of t in the form of u of t minus a into f of t minus a. So both these are, this one and this one, both are same. Now let us discuss some examples. Among these examples, we have discussed 4 examples in our previous lecture. Now let us see fifth example. Fifth example is, find Laplace transform of e power minus t into u of t minus 2. So here, if Laplace transform of e power minus 3t into u of t minus 2 has to be evaluated, then we have to use this definition. If L of f of t equal to f of s, then L of u of t minus a into f of t minus a equal to e power minus as f of s. When you observe this given term, here this u is in the form of u of t minus a, but here e power minus 3t is not in the form of f of t minus a. Here f of t, this is in the form of f of t. F of t equal to e power minus 3t. Then find its Laplace transform. Then L of f of t equal to L of e power minus 3t, that is 1 by s plus 3, which is equal to f of s. We need this f of s while evaluating this Laplace transform. That's why first we have evaluated Laplace transform of this function f of t. So here we have used 1 by Laplace transform of e power minus at formula. Laplace transform of e power minus at equal to 1 upon s plus a. By using this formula, here we have evaluated Laplace transform of e power minus 3t. Now, to find Laplace transform of e power minus 3t into u of t minus 2, first we have to express this e power minus 3t in the form of e power. This power should be in terms of t minus 2. To express this power in terms of t minus 2, let us add and subtract this number 2, because here in the place of a, 2 is there. Here u of t minus a equal to u of t minus 2, that is a equal to 2. So to express f of t in the form of f of t minus a, here you should include this a, right? So here we have added and subtracted this 2 here in this power. Now this can be written as e power minus 3 into t minus 2 plus minus 3 into 2, or here minus 3 into t minus 2 plus 2 can be written as minus 3 into t minus 2 plus 2, which is equal to minus 3 into t minus 2 minus 6. Okay, so here we get e power, here e power minus 3 into t minus 2 minus 6. Now you can split it, because if you have this expression in the power, then this can be written as e power minus 3 into t minus 2 into e power minus 6. You can split this in this way. That's why here I have written this expression in the form of e power minus 3 into t minus 2 into e power minus 6 into u of t minus 2 as it is, no change. Now e power minus 6 is constant, so we can write it outside. So e power minus 6 into Laplace transform of e power minus 3 into t minus 2 into u of t minus 2, which is equal to e power minus 6 as it is, no change. But here to find Laplace transform of this, we have to find e power minus a as f of s. Here value of a is 2, we have seen. So in the place of a, we should write plus 2, and in the place of f of s, we should write Laplace transform of f of t, which is equal to f of s, that is 1 by s plus 3. So if we write these terms in this definition, then we get e power minus 6 into e power minus 2 into s into 1 upon s plus 3. That is, if you club these powers again, we get e power minus 2s minus 6. If you take minus sign outside, we get e power minus of 2s plus 6 upon s plus 3. This is Laplace transform of e power minus 3t into u of t minus 2. Now let us see next example. Find L of f of t, where f of t equal to t square plus 1 when t is greater than or equal to 2, 0 when t is less than 2. Now capital F of t equal to f of t minus a. Here this is in the form of only t, but we should write it in the form of t minus a when you consider capital F of t. Here given f of t is small f of t, but we need capital F of t to find Laplace transform of capital F of t. Here capital F of t is given, but given function is in terms of small letters. That means this is only function f of t, which is in terms of t. But we need capital F of t. What is definition of capital F of t? Capital F of t is nothing but f of t minus a and 0, right? So to get that f of t minus a, here let us, here what is a? First identify a. What is a? Here t is greater than or equal to 2, t is less than 2. That means a equal to 2. So we should write this expression in terms of t minus 2. That's why here in the place of t, we have written t minus 2 plus 2. We have added this a and subtracted. So t minus 2 plus 2 whole square plus 1 when t is greater than or equal to 2 and 0 when t is less than 2. Now here if you consider t minus 2 as a single term, then you can expand this using a plus b whole square identity. If you consider this as some x plus y, so x plus y whole square, that is x square plus 2xy plus y square. That means t minus 2 whole square plus 2 into 2 into t minus 2, that is 4 into t minus 2 plus 2 square is 5. 2 square is 4. 4 plus 1, that gives 5 when t is greater than or equal to 2. Now here next value is 0 when t is less than 2. Understood? So now we have changed, we have converted this function f of t into f of t minus a. So this is definition of capital F of t. Right? Now we can find Laplace transform of this using this formula. Using the formula of Laplace transform of capital F of t. So here Laplace transform of capital F of t is f of e power minus as f of s. Laplace transform of capital F of t is e power minus as f of s. Right. So to get this f of s, we need f of t. So here what is f of t minus a? F of t minus 2, which is t minus 2 whole square plus 4 into t minus 2 plus 5. Here a equal to 2. Then here by observing this expression we can write f of t. F of t equal to t square plus 4t plus 5. Now let us find Laplace transform of this, that is L of f of t, which is Laplace transform of t square plus 4 into Laplace transform of t plus 5 into Laplace transform of 1. That gives 2 by s cube. Here Laplace transform of t power n. We have to apply Laplace transform of t power n formula, which is equal to n factorial by s power n plus 1. If you use this formula, you get here Laplace transform of t square equal to 2 factorial upon s cube, that is 2 by s cube, plus Laplace transform of t is 1 by s square, but 4 is there, so 4 by s square, plus Laplace transform of 1 is 1 by s, that is you get 5 by s because 5 is there. So this is Laplace transform of capital F of t. Is it capital F of t? This is Laplace transform of small f of t. But we need Laplace transform of capital F of t. So to get Laplace transform of capital F of t, we should use this formula e power minus as f of s, that is e power minus as into Laplace transform of small f of t, that is e power minus 2s into this whole expression 2 by s cube plus 4 by s square plus 5 by s. Here a equal to 2, that's why here we have written e power minus 2s. So this is Laplace transform of small f of t equal to t square when t is greater than or equal to 2, 0 when t is less than 2. Now let us see next example. Find the Laplace transform of capital F of t equal to 2 in the interval 0 to pi, 0 in the interval pi to 2 pi, and sin t in the interval 2 pi to infinity, that is when t is greater than 2 pi. Now here this limit can be written as this is equal to 2 pi less than t. Now we can express this capital F of t in the form of u of t minus a into f of t minus a. Here we can express this in the form of u of t minus a into f of t minus a. So how can we express? Let us see. Here this value of this function 2 into u of t minus lower limit minus u of t minus upper limit. So here lower limit is 0, upper limit is pi. So what do you get? U of t minus 0 minus u of t minus pi plus now second value of this function, that is 0 into u of t minus lower value, So t minus pi minus u of t minus 2 pi plus this third value, that is sin t into u of t minus 2 pi, because 2 pi is lower limit, right? So sin t into u of t minus 2 pi. Here upper limit is not given. So here we have taken only lower limit. Now let us simplify this. Here t minus 0 is t. That's why here you get 2 into u of t minus 2 into u of t minus pi, plus here 0 into this whole thing, that becomes 0. Here plus sin t into u of t minus 2 pi. Now Laplace transform of f of t, capital F of t, equal to Laplace transform of this whole expression. So L of 2 into u of t minus 2 into u of t minus pi plus sin t into u of t minus 2 pi. Now here you can apply linearity property. So we get 2 into Laplace transform of u of t minus 2 into Laplace transform of u of t minus pi plus Laplace transform of sin t minus 2 pi u of t minus 2 pi, because in this expression sin t is given. So sin t is not in the form of f of t minus a. So here we should write this t in the form of t minus 2 pi. That's why here we have written this sin t as sin t minus 2 pi plus 2 pi. Here t minus 2 pi, if you consider t minus 2 pi as theta, then you get sin 2 pi plus theta. Sin 2 pi plus theta means it is in first quadrant. In first quadrant, sin 360 plus theta. In first quadrant, sin is positive, right? Sin is positive. So you get same thing, sin t minus 2 pi. Sin theta, because sin 360 plus theta sin 360 plus theta equal to sin theta. So sin of 2 pi plus t minus 2 pi equal to sin of t minus 2 pi. That's why here we got sin t minus 2 pi into u of t minus 2 pi. Now for each and every term we should use these formulae. L of u of t, Laplace transform of unit step function, that is 1 by s. So here 2 into 1 by s minus 2 into Laplace transform of u of t minus a equal to e power minus as upon s. When you compare this with this one, in the place of a you can find pi. So here we get e power minus pi s upon s plus here Laplace transform of f of t minus a into u of t minus a equal to e power minus as into Laplace transform of f of t. So here a is 2 pi. So e power minus 2 pi s into Laplace transform of, here f of t is sin t. F of t is sin t. F of t minus a is sin t minus 2 pi, right? So here we got L of sin t. Now this is nothing but 2 by s minus 2 into e power minus pi s upon s plus e power minus 2 pi s into Laplace transform of sin at equal to a by s square plus a square. So Laplace transform of sin t is 1 by s square plus 1. Okay. So if you simplify this, you get 2 by s minus 2 into e power minus pi s upon s plus e power minus 2 pi s upon s square plus 1. So this is Laplace transform of given function. Now let us see one more question. Find Laplace transform of capital F of t, where f of t equal to 1 in the interval 0 to 1, 2 in the interval 1 to 2, 3 in the interval 2 to 3, 4 in the interval 3 to 4, so on. So the function f of t can be expressed. So let us express this given function in the form of u of t minus a, f of t minus a first. So capital F of t equal to first value 1 into u of t minus 0 minus u of t minus 1 plus 2 into u of t minus 1 minus u of t minus 2 plus 3 into u of t minus 2 minus u of t minus 3 plus so on. Now if you simplify this, you get u of t minus u of t minus 1 plus 2 into u of t minus 1 minus 2 into u of t minus 2 plus 3 into u of t minus 2 minus 3 into u of t minus 3 plus so on. So here u of t plus, if you observe this, 2 into u of t minus 1, here minus u of t minus 1. So if you simplify these two, you get u of t minus 1. In the same manner, here you can observe u of t minus 2 terms. Here two terms, that is 3 in u into t of 3 into u of t minus 2 minus 2 into u of t minus 2. This gives u of t minus 2 plus so on. Now let us apply Laplace transform on both sides. That is L of capital F of t equal to L of u of t plus u of t minus 1 plus u of t minus 2 plus so on. So Laplace transform of u of t plus Laplace transform of u of t minus 1 plus Laplace transform of u of t minus 2 plus so on by linearity property. Now let us find Laplace transform of each term. Here Laplace transform of u of t is 1 by s plus Laplace transform of u of t minus a is e power minus as upon s. So you get here a equal to 1. So you get e power minus s upon s plus here a equal to 2. So you get e power minus 2s upon s. For the third term a equal to 3. So here we get e power minus 3s upon s plus so on. Okay, because by using this formula L of u of t minus a equal to e power minus as upon s. Now if you take 1 by s outside, we get 1 plus e power minus s plus e power minus 2s plus e power minus 3s plus so on, which is equal to 1 by s into 1 by 1 minus e power minus s, because this can be written as 1 plus e power minus s plus e power minus 2s plus e power minus 3s plus so on, can be written as 1 plus e power minus s raised to 1 plus e power minus s whole square plus e power minus s whole cube plus so on, which is equal to 1 minus e power minus s raised to minus 1, because 1 minus x raised to minus 1 equal to 1 plus x square plus x cube plus so on. So this expansion can be written as 1 minus e power minus s raised to minus 1. So that means 1 by 1 minus e power minus s. That's why here we got this 1 by 1 minus e power minus s, which is equal to 1 by s. Here if you take e power minus s outside, which is equal to 1 by e power minus s into here 1 by e power minus s. If you take e power minus s common, you get 1 by e power minus s minus 1. So you can write it in numerator. If you write it in numerator, you get e power s. This power becomes positive when you write it in numerator. So this becomes e power s by, here it is 1 by e power minus s. So again it becomes e power s minus 1. So Laplace transform of given function is 1 by s into e power s by e power s minus 1. Let us see next example. Find Laplace transform of f of t, where capital F of t equal to 1 in the interval 0 to 2, 2 in the interval 2 to 4, 3 in the interval 4 to 6 and 0 when t is greater than 6. Okay, so here this function, again this can be expressed in the form of f of t minus a into u of t minus a. U of t minus 4. So here capital F of t can be expressed as 1 into, here lower limit, that is 0, that's why u of t minus 0 minus u of t minus 2 plus 2 into u of t minus 2 minus u of t minus 4 plus 3 into u of t minus 4 minus u of t minus 6 plus 0 into u of t minus 6, because this is 6 is less than, this can be written as 6 is less than t. That's why here you get 0 into u of t minus 6. When you simplify this, here you get u of t minus u of t minus 2 plus 2 into u of t minus 2 minus 2 into u of t minus 4 plus 3 into u of t minus 4 minus 3 into u of t minus 6. Here last term becomes 0. Now here there are two terms which are u of t minus 2. Here plus 2 minus 1. That gives u of t minus 2. First term is u of t. Here again you can observe there are two u of t minus 4 terms. So here you get u of t minus 4 because this is plus 3 and minus 2, that's why. And here minus 3 into u of t minus 6. Okay. So similar terms we have added. Now let us apply Laplace transform on both sides. Then we get Laplace transform of f of t equal to Laplace transform of u of t plus Laplace transform of u of t minus 2 plus Laplace transform of u of t minus 4 minus 3 into Laplace transform of u of t minus 6, because this last term is negative. That's why here we got minus 3 into Laplace transform of u of t minus 6. So Laplace transform of u of t is 1 by s plus Laplace transform of u of t minus 2 is e power minus as upon s. Here a equal to 2. That's why we get e power minus 2s upon s. Here e power minus 4s upon s minus 3 into e power minus 6s upon s. So when you take 1 by s outside, we get 1 by s into 1 plus e power minus 2s into e power minus 4s minus 3 into e power minus 6s. This is Laplace transform of given function. Let us see one more example. Here capital F of t equal to 0 when t is between 0 and pi by 2 and sin t when t is greater than pi by 2. Again let us express this in the form of f of t minus a u of t minus a. So here first value 0 into u of t minus 0 minus u of t minus pi by 2 plus sin t into u of t minus pi by 2, because this can be written as pi by 2 is less than t. T is greater than pi by 2 means pi by 2 is less than t. So you can write sin t into u of t minus pi by 2. Okay. Now here this term becomes 0 because here it is 0. So sin t should be expressed in the form of t minus pi by 2. So we have added and subtracted pi by 2. T minus pi by 2 plus pi by 2 into u of t minus pi by 2, which is equal to cos of t minus pi by 2, because sin pi by 2 plus theta, sin 90 plus theta equal to cos theta. So sin pi by 2 plus t minus pi by 2. So you can observe t minus pi by 2 in the place of theta, which is equal to cos of t minus pi by 2. So here you get cos of t minus pi by 2 into u of t minus pi by 2. Okay. Now L of f of t. Now apply Laplace transform. So L of f of t equal to L of cos t minus pi by 2 u of t minus pi by 2. Now here this is equal to e power minus as f of s. So here e power minus as, that is e power minus pi by 2s into L of f of s means L of f of t, that is L of cos t, because this is cos of t minus pi by 2, that is nothing but f of t minus a. Okay. So cos t equal to f of t. So f of s equal to L of f of t. That's why here we got L of cos t. L of cos t is s by s square plus 1. So its Laplace transform is s into e power minus pi s by 2 upon s square plus 1, because you can multiply these s and e power minus pi s by 2. So this is Laplace transform of given function. Let us see last example. Find Laplace transform of f of t equal to t minus 1 when t is between 1 and 2, 3 minus t when t is between 2 and 3. So here the function f of t, again express this in the form of f of t minus a into u of t minus a. So here this is not small f of t, capital F of t equal to small f of t is given. We are expressing this in the form of capital F of t. So capital F of t equal to t minus 1 into t minus 1 into u of t minus 1 minus u of t minus 2 plus 3 minus t into u of t minus 2 minus u of t minus 3. Okay, here u of t minus 1, now simplify this, t minus 1 into u of t minus 1 minus t minus 1 into u of t minus 2 plus 3 minus t into u of t minus 2 minus 3 minus t into u of t minus 3. Now, if you observe, here u of t minus 1 is here only in this first term. So, t minus 1 into u of t minus 1 as it is. But u of t minus 2 you can observe in two terms. In second and third terms, you can find u of t minus 2. Okay. So, here if you take u of t minus 2 common from these two terms, you get t minus 1 plus 3 minus t, right? Here it is, I have written 3 minus t as minus of t minus 3. Then we have taken this minus sign out. So, t minus 1 plus t minus 3 into u of t minus 2. Plus, again last term as it is, no change. So, here this is 2t minus 4. 2t minus 4 can be written as 2 into t minus 2. Right. So, first term as it is, second and third terms, they together, they become 2 into t minus 2 into u of t minus 2. And last term as it is, t minus 3 into u of t minus 3. Right. Now, let us apply Laplace transform on both sides. So, Laplace transform of capital F of t. Here this is capital F of t. Laplace transform of capital F of t equal to L of t minus 1 into u of t minus 1 minus 2 into L of t minus 2 u of t minus 2 plus Laplace transform of t minus 3 u of t minus 3. Here we have to apply this formula to find Laplace transform. L of f of t minus a into u of t minus a equal to e power minus as f of s. So, let us identify a in each and every term. So, in first term a equal to 1. That's why we get e power minus s into 1 upon s square. Here minus 2 into here a equal to 2. So, you get e power minus 2s into 1 by s square. Then here in this third term, you get e power minus 3s into 1 upon s square. How do you get this 1 upon s square? Here f of t minus a. F of t minus a equal to, it may be t minus 1, t minus 2 or t minus 3. Here f of t will be t only. F of t equal to t. Then L of f of t equal to Laplace transform of t. Laplace transform of t equal to 1 upon s square. That's why here we got 1 by s square in each bracket. Now if you take 1 by s square common, you get e power minus s minus e power minus 2s plus e power minus 3s. Okay. Again you can take e power minus s outside. Then you get e power minus s upon s square into e power minus 2s minus 2 e power minus s plus 1. Here in the place of e power minus s you get 1. Here you get, here it is. So, again here you get minus 2 into e power minus s. Again third term will be plus e power minus 2s. Okay. So, I have written this 1 at the end. That's all. Now, here again this is nothing but 1 minus e power minus s whole square. A square minus 2ab plus b square. So, you can write it as e power minus s into 1 minus e power minus s whole square upon s square. So, this is Laplace transform of this given function. So, in this session, we have discussed some 5 examples, and in each example, we have expressed the given function capital F of t in the form of f of t minus a u of t minus a. Then we have evaluated Laplace transform of a given function. Thank you. Let us meet in next session.